July 1, 2025. Astronomers across the globe woke up to the news that would rewrite cosmic history, the discovery of 3I/Atlas, the third ever confirmed interstellar visitor to enter our solar system. But just as celebration erupted, something strange happened. Moments after the discovery went public, some of the world's top telescopes, Hubble, Gemini, and VLT suddenly went dark. At the same time, Chinese observatories released stunning new images of the object, revealing details that Western scientists could no longer confirm in real time. Let's break down what happened, why 3I/Atlas is unlike anything we've ever seen, and how a global blackout at the height of discovery has triggered one of the most intense scientific debates in years. The official discovery bulletin for 3I/Atlas hit international science wires just after midnight UTC. It came from the Atlas Survey Team, operating out of Hawaii and Chile, designed to spot near-Earth asteroids and potential impact threats. What they found, however, was moving too fast and too freely to belong to our solar system. Within hours, orbital calculations confirmed the impossible. This wasn't a comet tied to the sun's gravity. It was interstellar, a cosmic messenger from beyond. By dawn, the Minor Planet Center had given it the official designation 3I/Atlas, meaning the third identified interstellar object, following Oumuamua, 2017, and Borisov, 2019. But there was something different this time, something that made scientists sit up. Unlike the dry, rocky Oumuamua or the icy, comet-like Borisov, 3I/Atlas seemed to be both, a hybrid object. It had a visible coma, a dusty tail, but its nucleus appeared solid, large, and strangely stable. As word spread, every major observatory scrambled to aim their instruments at the fast-moving visitor. The data suggested 3I/Atlas was roughly 30 to 50 kilometers wide, far larger than any previous interstellar object detected, and traveling at an inbound speed over 60 kilometers per second. That's over 134,000 miles per hour, fast enough to cross the distance from Earth to the Moon in just over an hour. Teams from NASA, ESA, China's National Astronomical Observatory, and even amateur astronomers rushed to collect every photon of data they could before it vanished back into the dark. Just as Chinese observatories began sharing crisp, high-resolution images of 3I/Atlas, showing what looked like complex surface features and a rotating jet pattern, multiple Western telescopes went offline. The timing was too sharp to ignore. The Gemini North and South telescopes in Hawaii and Chile, both critical to early observation, reported temporary power and data synchronization issues. The Very Large Telescope, VLT, in Chile entered a scheduled maintenance mode, hours after the discovery bulletin. And the Hubble Space Telescope experienced what NASA described as a synchronization anomaly. All of this, just as 3I/Atlas entered its best viewing window. Now, scientists maintain that these were likely coincidences, routine calibrations and maintenance, but across social media and science forums, suspicion ignited. Meanwhile, images released from Chinese observatories sent shockwaves through the astronomy community. Their instruments, operating from ground-based observatories in Tibet and Yunnan, showed something never before seen in an interstellar object: a distinct surface banding pattern that appeared to rotate and pulse as the object moved closer to Mars's orbit. Headlines began asking whether the timing of the telescope blackouts might reveal deeper issues in data transparency and international cooperation. For years, global observatories have maintained open-access data archives, but in moments like this, national priorities can clash. Some independent researchers accused major agencies of data throttling to control the narrative about what 3I/Atlas might be. NASA and ESA firmly denied it, insisting that every downtime incident was logged and routine. If 3I/Atlas truly behaved unlike any known comet or asteroid, then even a small delay in releasing data could mean losing once-in-a-lifetime evidence about the building blocks of another star system. Here's what scientists can confirm as of now: 3I/Atlas entered the solar system on a steep hyperbolic trajectory, meaning it's not bound to our sun. It is roughly 30 to 50 kilometers in diameter, making it the largest interstellar object ever detected. It has an active coma and tail, rich in carbon dioxide, with less water vapor than expected, suggesting it formed in a colder, more distant environment than our own Kuiper belt. Its rotational dynamics show an unusual nonlinear spin, still under study. and it will make its closest approach to the Sun around late October 2025, before leaving our solar system forever. Each observation adds another layer to the mystery, and raises new questions about what else might be passing through our system unseen. Since its discovery, international teams have begun preparing a coordinated observation campaign involving JWST, ground observatories, and AI-assisted image processors. NASA's Planetary Defense Coordination Office has even flagged 3I/Atlas for continuous monitoring, not as a threat, but as a high-priority data target. Meanwhile, citizen astronomers continue to upload thousands of images and light curve readings, trying to fill in gaps from official data blackouts. The excitement has spilled beyond scientific circles, sparking documentaries, debates, and deep discussions about the limits of human cooperation when faced with the unknown. So, what do the new Chinese images really show? Why did several of the world's top observatories suddenly go offline during the biggest discovery of the decade? And could 3I/Atlas be carrying secrets about how our own solar system began? The story is still unfolding, and the next few months could change how we see interstellar visitors forever. Stay tuned, because as new data emerges, one truth becomes clear: the more we look to the stars, the stranger they become. Subscribe now to follow every update, discovery, and mystery behind 3I/Atlas, the interstellar visitor that arrived when the telescopes went dark. Thank you for watching my channel.